guys, welcome back to my channel TechFit. This is Garv. So today I want to cover a really interesting topic, which is a day in life as a data scientist and working on a real life problem and what that problem does look like. This would give you a good understanding if you're trying to move into this field, what type of task you would be performing as a data scientist. That might give you a good understanding of this field. We won't be looking at the source code for this. Again, this is more just to kind of show the actual implementation of this project. Now, this is not really the complete project. Obviously, I have advanced this project to another level. But again, this gives you a really good understanding of how does a whole project does look like. If you think I'm talking too fast and maybe the things are not clear to you, you can actually reduce the speed of this video by controlling it through the YouTube controls. So once you exactly understand the question that's been asked by the business, and secondly also that you exactly know your audience, the second thing then is to actually underline what type of data you need for your analysis. Again, when we're talking about the type of data that you need from the analysis, the data would be stored in the database, which you do have to extract, and for that you do need to understand some basic understanding and knowledge of SQL. So again, I do have another video in which I actually go into the basics of SQL, so do watch that video if you're looking to learn how to actually use SQL when you're actually working with markup languages, again when you're trying to extract the data from the database. Once you have the access to the database and you understand what type of data is actually available to you to use from the business database, then you have to understand if there is any third-party data set that you can actually use to enhance your analysis. So an example for that would be maybe using census data if your analysis is actually trying to find proactive leads or actually retain more customers and you want to create more understanding about your population. You can actually use census data and overlay on your own database to actually understand more about those customers. So once you have all that covered, then the first step in the analysis would be to actually perform some exploratory data analysis, where you're trying to understand your data and trying to see what exactly is there within the database. To understand your descriptive analysis, the type of customers that you have, and your diagnostic analysis to understand what exactly are the customers that are getting impacted and why are they getting impacted. Once you understand your customers and you exactly know why they are leaving, then you can actually build some predictive models to actually predict the customers that are more likely to leave and do something about those customers. If the question is to actually retain more customers, then we will build a churn model to actually predict the customers who are more likely to leave the company. Then we actually do something to actually retain those customers, maybe send them new offers and maybe send them more competitive prices to actually still retain those customers within our business. Once you're building those predictive models, again, within those predictive models, before that you would have done some diagnostic analysis in which you would actually do more feature engineering, where you're actually trying to build some features that you think will be really useful in terms of predicting that these customers are more likely to leave, and these could be one of the reasons why they are leaving. And then the final stage of your project would be prescriptive analysis, which is how do we do something about those customers to actually retain them. Again, as I said before, with an example, that if you think that these customers are more likely to leave and this is one of the reasons why they're leaving, again, that could be that the prices of the product has gone up, or if there's something specific that is actually triggering those customers. So you do something about those customers by offering them a better product. What are the key triggers that are actually triggering these customers to leave the company? Again, you find those triggers and basically you try to amend them. Maybe if there's some reason, maybe they got a bill shock, or if there's some specific product that they were on, the prices have gone up, then they do something about those, or maybe provide them with a better offer and try to retain those customers. So now we will look at this project where I'll go in more detail on what are the exact questions that are being asked to me as a data scientist and how did I actually end up resolving those questions. The idea behind this video is not to give you the actual source code of the analysis, but it is more to actually give the feel for this field, where if you're working as a data scientist, what type of task you'll be performing as on a day-to-day life. So sit back, relax, and let's start elaborating more on this project. So let's start looking at the project itself. So first of all, I'm going to explain what are the types of questions that are being asked by the business. So if you're working in any company, you might be asked to actually create a new sales strategy. Again, within that, what we're trying to answer is like, how can we actually acquire right new customers for the business? The second would be how to create customer retention strategy. Again, within that, what we're trying to do is once we have acquired new customers, we want to see how can we actually retain these customers, or if the customers who are already within the business, how do we actually retain those customers? The third would be cross and upsell strategy. Again, once we have acquired new customers, how do we actually cross-sell or upsell different products of the company to the customer? Again, because the more product you sell to the customer, the more valuable the customer becomes. Also, company makes more profit when they're selling different products to the same customer. One of the main benefits of cross-sell would be, again, if you're cross-selling a product to a customer who already exists in the company, will be much easier in comparison to if you're going out and trying to acquire new customers. This would be a caveat related to the business, but again, depending on a business, it will be 5 times more expensive to actually acquire a new customer in comparison to selling some services to an existing customer. And retaining an existing customer would be less expensive in comparison to actually acquiring a new customer. So initially starting with the business objective, again, main key problems with most of the companies is not just to acquire more customers, but it is to actually acquire right new customers and retain them. This project was data optimization network, which kind of like focuses more on 3 core techniques, which is data extraction and manipulation, advanced analytics, and visualization dashboards. Again, the idea behind this project was to actually use data optimization network to improve business decision making using machine intelligence and data science techniques. Again, within this project, I was working on predicting customer behavior, building value model, market trend optimization, address matching, and fraud anomaly detection. Again, project is also trying to help in terms of valuing customer trends for enabling business user to build proactive sales and retention strategies. Again, the shiny dashboards are created which will enable the research and understanding of market trends and customer behavior, on the basis of which leads will be generated through using drill down reporting. Again, this was the overall view and objective of the project. Again, if you're not really too sure about using Shiny apps or you're not really used to working with R coding, I'll kind of like break it down for you to make it more simpler. As you can see in the slide itself, I've used different packages within R. But if you look at these 2 nodes, basically which is your 2 different nodes. So one is your UI.R, which is the user interface, where a user actually goes into the application, clicks different button, which actually sends the user input towards server.R, where basically the actual computation happens, which is the input and output functions. And once basically your graphs or whatever tables are being created within that function, and then basically that analysis sends that analysis back through the function output, which goes back to the UI.R, where actually the users can then see the analysis. Again, so within this project, I kind of like focused on using third-party dataset as well, which was census dataset. Again, within census dataset, one of the main factor for using census dataset was to actually first build a matching rules to actually bring database address levels also on the census levels. So if you kind of like look at an overall view, census data is more higher level. It could be looking at different small area boundaries rather than actually looking at a specific address. So within this project, I did address matching in terms of matching the addresses from one string to the other string, for which I've used Levenstein distance to actually match one string to the other string. Again, I don't want to go into too much detail on explaining what Levenstein distance is. Just to put it in really simple terms, it is an edit distance matching between 2 strings of addresses. So within the algorithm, there are 3 types of operation that happens, which is insertion, deletion, and substitution between one other address to actually match as close as possible to this address, which makes a perfect match. Once you are matching the address on this level, what we can then do is we can use the primary IDs of that table to actually bring it more higher level, which is a small area boundary level. Because again, within census data, there are different themes that I can use, such as family ties, family stages, and what occupation a person is on within the household, how many cars they have, how many people do travel from the house, how many people have internet in their house. So again, these type of different classification then can be used to actually create more features for your models. So that was the whole idea behind kind of like doing the address matching within the project. So secondly, then I looked at building value model and also looking at building the churn model, which gave more understanding through predictive analytics, what customers are more likely to leave and what's their probability score for leaving the company. Again, based on using value score and churn score, I built these segments which were then used to actually contact these customers. Again, within this project, there was a lot more feature engineering and understanding different data sets and basically creating those features and evaluating them through machine learning models to understand what features are more important and how they're impacting the customer behavior. And this is more like a detailed slide which kind of like looks at how the actual work was being conducted. So it kind of like shows an example of distance matching between 2 strings and how was the match rate was being calculated. Once the address matching was done, then I focused more on basically including that census data and adding those new features within our database. And then I focused more on building value model and churn model. And again, this example is quite similar. If I move from company to company, that's the type of analysis you would be doing for this certain type of project. This is just an overall view that how things actually plays out and how do they work with each other. What I want to kind of do is I want to give you a demo of the application to show you one draft version of how the dashboards were created and how they look like. And for this I use Shiny Dashboard, so I'll show you the application that I've built to give you a more brief understanding on how the analysis was created and what was the visualization looked like, and how can this be easily readable by the business itself if they're trying to understand what exactly is happening with their customers. So as you can see, application is built in Shiny app. So this is a Shiny app running on my machine, which again, you can see the R code on the background. And basically, if you see the front end of the application, so obviously we are looking at like geospatial maps of understanding what exactly is the churn in different areas, and also looking at census data, what type of families live in that area. Then you do have like more detailed view, which are more the hotspot leads. Again, if a business is trying to understand which areas were more focused within those churn areas, they can actually target it through this. And their different density clusters were created on the basis of what type of families are living in what area. And within that analysis, I elaborated more in understanding of current customer trend and where these customers are, what types of products they are buying, and also looking at different types of features that we can look at against those customers to understand how long they are with us and what are the different acquisition channels we acquire these customers from, what type of payments they're making, what's their consumption. And these are again dependent on more the actual product that you're aiming at. It also looks at different correlations that are happening between the data set. As you can see, we are building this correlation matrix. And going forward, it also allows the user to actually understand the census population and look at what exact area they're trying to capture, and to understand within that area what type of people are living. Within, for an example, you can also look at what type of occupation status they are on, and also going in more detailed view of understanding what is their occupation status, what is their, if they do have internet in the house, what type of gender living in that specific areas. What is the age group of the people? What is the type of household? What is the stages of family? So it kind of like looks at different themes within the census data. And then I also kind of like looked at different types of features and how do they impact the retention curves, and how do they look like in terms of if you're looking at customers' likeliness to leave, and depending on comparing it with different features. So there's a lot more kind of like goes that into the analysis itself. So even for building the models, again, there was first was the business objective, which was to actually predict which people are more likely to leave the company. Again, that's basically your binary classification of people leaving, which is yes and no, which is your target variable. And first of all, based on the dashboard itself, I had a good understanding on the data, and then moving towards preparing the data for actually to build the model. Again, within data preparation, you would be doing something like how to handle missing values and also cleaning the data, and then moving towards more feature engineering. And again, within feature engineering, I've done different models to actually predict, which is again using different cluster analysis to actually build some more features out of my data set, and also looking at different features that I could use with in terms of time domain or in terms of distance in the addresses. Then moving towards the modeling approach. Within the modeling approach, I first went on selecting different models. So obviously I trained multiple models, and out of that, based on the models that are more fitted to my data set, I selected them as my final models. And within those models, following the techniques of grid search to actually do more parameter tuning depending on what features can be played around within those models. And within the model, I trained it on 80% of the data set and tested on 20%. And I also applied it on different sample sets, such as I trained the model on 70% of the training set, and then I tested it on 15% of the test set, and also before that I validated the model on 50% of the validation set. And within that I also applied regularization on my model, and also applied k-fold cross-validation to get an average accuracy on my models. Finally, based on that, I selected top 3 models, and on those 3 models, then I basically built a voting system, which is basically when 2 models are basically predicting that these customers are more likely to leave. I use that binary flag as yes for those customers that they are more likely to leave, and using an average probability score. And finally, based on that, I deploy these models in productions to run them on weekly basis, and actually to monitor them as well on ongoing basis, and include new features that I find in future and they're more interesting to actually predict the customer behavior. And also looking at different segmentation on the geo maps. So within that, I also created these segments, which is the conjunction of value and churn model. And also looking at the customers who have a higher probability to leave the company on the spatial map and where they are located. And on the basis of overlaying that with the census data to understand what type of population live in that area. And also looked at the different heat maps to understand where the actual heat is coming from in terms of which area is more impacted, and also looking at in terms of the value scores where I can see exactly where more valuable customers are living if I'm looking at on an overall geographical level. And again, this is more just an overall view of the analysis, how the dashboard actually looks like. This is just to kind of like give you an understanding of what actual projects look like once they are finished. And again, there's a lot more goes within this. Like you have a lot of questions to answer the business. There are a lot of questions might come back to you, which you go back and try to do different types of analysis and try to answer those questions. Again, the overall analysis that I'm actually showing it to you is all just done on the basis of random data at the moment. It's just a draft copy just to kind of show you the power of Shiny app. If you're working in a data science field and if you are doing R programming, again, you can do something like this within your programs. Again, do check out this another video which I created, which was how would I learn data science if I have to start all over again, in which I kind of like go in comparison of Python and R. If you're choosing one of the languages for your data science career, again, it kind of like goes in more detail on pros and cons of both the languages and what would be my ideal language. So this is kind of like an end-to-end review of a project. And again, this is just an extra project that I worked on. It's nothing to do with any of the companies. It's just to show you an overall example of if you're working in this data science field, what a project would look like from end to end. Again, this is just a draft copy of this project, which kind of like shows you, it gives you a feel of the project. And if you're working with R programming, or if you're even working with Plotly Dash and Python, what is the end goal that you can achieve out of your Dash? And again, there was more to this project and how did I answer these questions and how did I basically connect the end-to-end application itself, because it was not just to build this fancy application, it was more to basically create that understanding and give that understanding to business from end to end. And say for an example, if I built an anomaly detection model to show where these anomalies are and actually to look at where we can target in these areas to actually do something about this, which is a prescriptive analytics where you actually do something about what you have found through your findings. Again, with those findings, then you do something about, maybe it could be a solution that you think based on the results that you see, and if there's any type of correlation or if there is any features that triggered out more, you can basically explain that to business and basically create some sort of solution that actually impacts that. And if you do make some changes within this, it's more about to actually see that change and evaluate it and see if you made this change, did it actually help, or was there a value add that something you did. Say for an example, one of the questions I was trying to answer out of this analysis was to retain more customers. And say for an example, if the retention was 5% before, based on building the churn model, based on contacting these customers who were high likely to leave the company, and once we did take some actions on top of that, did it actually increase the retention rate? Was the retention rate moved from 5% to 6% to 10%? To do all these evaluation analysis, this is all what you do if you're working as a data scientist. So I hope you enjoyed this content. It gave you some sort of value add, or gave you some sort of feel of this field. If you liked the video, give it a thumbs up. And please subscribe to my channel. It definitely helps the YouTube algorithm to actually pick up my videos and show it to people who are actually interested in these topics. And thanks for doing that. I really appreciate you supporting this channel. I'll see you in the next video. Peace out.